All right, so in 2.7, we're going to look at these one-to-one functions and their inverses. Okay, and when you are doing the inverses, linear is something you've done before, but we're going to extend this to quadratic rational square roots. And we are also going to explain the meaning of inverses in real world problems. So the first thing we're going to talk about is how to find the inverse. So it says switch f of x to y. Okay, you're not going to have to write like that step down, but here's your like f of x equals is the same thing as y equals. Okay, and then you are going to switch the variables. Okay, so when you switch the variables, instead of y equals, you're going to have x equals. Instead of 6x, you'll have 6y. Okay, and then after you switch, you are going to solve the equation for y. Okay, so you're going to solve for y. So we switch, and then we solve. Okay, and then when you write your solution, you just want to write that in inverse notation. Okay, so that will be our last step there. Okay, so if I'm solving for y, in terms of work, I'm fine if you write it like this, like you are adding the 8 over there, okay, and then you're dividing by 6. Anytime it's a linear, we really do want to write this so it's in slope-intercept form, which would be 1/6x plus, and then 8 over 6 you can reduce. So 2 goes into both, it would be 4/3. Okay, so then your inverse, we're going to use inverse notation. So 1/6x, or you could leave it as x over 6 plus 4/3. Okay, that way you are reducing. Okay, so anytime it's linear, we want y equals mx plus b form. All right, and then for part B, we have f of x equals x to the 7th minus 7 over 6. Okay, and it's okay if your first step is just rewriting this as x equals y to the 7th minus 7 over 6. Okay, but your work here is showing your algebra steps for solving. Okay, so we want to get y to the 7th by itself, so go ahead, you can write down what your next step is to solving. All right, so when you are deciding what to do here, if you have division, then you are going to want to multiply. Okay, so again, I just need to see that step. Okay, your work for these is the solving. Okay, so that's what we want to see here. So show that you're going to multiply both sides by 6. Okay, so then you have 6x is equal to y to the 7th minus 7. I'm okay if your next step is just plus 7 equals y to the 7th. And then we do need to show that we are taking the 7th root of both sides. Because if it's a power, you're going to use a root. That's the inverse. Just like if it was y squared, you would use your square root. Okay, and then we're going to change that to inverse notation. So anytime you're writing your inverse, you want to have that notation there. All right, and then for C, we're going to look at a square root. So we have f of x equals the square root of x minus 6 Okay, so if you want to switch x and y to start, please feel free. We have to undo that root. How do you undo a root? Yep, we're going to use a power. So if it's a square root, we're going to square both sides. X squared is equal to y minus 6, which means x squared plus 6 is equal to y. Okay, so this is going to be your inverse. All right, now we are going to do a rational function. So when you have a rational function, you could have a variable in the numerator and the denominator. So we have f of x is equal to 4x minus 2 over 3x plus 1. So in your first step, when you're switching these, you are going to plug in y for both. So you have 4y minus 2 over 3y plus 1. All right, so just like we did last time with the division, when you have something on the bottom, you want to multiply to get that out of the denominator. Okay, so your first step, and I'm just going to write what I'm doing to the side here because these are the ones I get the most questions about. So I would like you to have the steps on the side. Okay, so you're going to multiply by the denominator, even if there's a variable in the denominator. So we're going to multiply both sides by the quantity 3y plus 1. Okay, so on this side, it cancels. You have 4y minus 2. Okay, on this side, we are going to distribute. Okay, so once you distribute, we write that down there. So 3y times x. You can just write that as 3xy. Usually we put them in alphabetical order. Okay, and then x times 1 would be plus x. Once you have this, you want to move all the y terms to one side. Okay, and then all the other ones are going to go to the other. Okay, generally we move them to the left. Okay, but you don't have to do that. You might do an equivalent version. So if I'm moving 4y over, okay, I want 3xy minus 4y equal to, and at the same time, I'm going to subtract x from both sides. Now here's the reason why you want to do that. When you have all your y terms on one side, y becomes the GCF, so you can factor out the y. Okay, even if there's a number that can come out, you don't have to do that. Only factor out the y value, because now you have one y term. If you take out the y, it's just division. This would be 3x minus 4, right? That factoring is really the distributive property in reverse. So if you were to multiply this back, you should get the same thing. Okay, and then your last step is just to divide. So divide by the quantity 3x minus 4. Okay, so then your inverse is going to be negative x minus 2 divided by 3x minus 4. Okay, and you can leave it just like that. Okay, if you wanted to factor the negative out of the top, that would be an equivalent form, but you don't have to do that. Okay, so I want you guys to try that with part E. F of x equals 3x divided by x minus 2. Okay, so I'm going to give you a minute to do that. And it's okay if you try something and make a mistake. You want to try it on scrap paper and then go back, you can. Okay, so again, when you're doing this, I am looking for these algebraic steps here. Okay, so you're showing what you're multiplying by. So it's y squared. So you will get 3y is equal to xy minus 2x. Okay, and then when you're reorganizing these, I'm fine if you do xy minus 3y equals 2x. Okay, so we subtracted the 3y, we added that over, and then you're factoring out your y. Okay, so then your final step, your inverse is going to be 2x divided by x minus 3. All right, any questions for me on the front side? All right, let's talk some story problems. Okay, so in example 2, it says the amount of a commodity that is sold is called the demand for the commodity. The demand D for a certain commodity is a function of the price given by this equation. Okay, so one thing that's really helpful when you are doing these where you have to say what the inverse represents is finding what your input and your output are going to be. When you're finding the inverse for a real life problem, you are not switching the variables, okay, because they are tied to a specific unit. Okay, so we're just going to write that note down. And finding the inverse. For a real world problem, do not switch the variables. Okay, you are going to solve for the current input. So if we look at this equation here, the current input is going to be P. So that's what we are going to solve for. So it says D of P. It's fine if you write it as D equals negative 3P plus 150. Generally, they'll leave it like that so it's a little bit easier. And we are going to solve for P. Okay, so our first step would be to subtract 150 from both sides. Okay, so that is your first step. Your next step is to divide. And this is a linear, so we're going to write it as negative 1/3 D plus, and then 3 goes into 150 how many times? 50. Okay, so this is your value. This is the inverse. So once you have this, you can write that the D inverse is negative 1/3 D plus 50. Okay, now keep in mind these are tied to these variables. Okay, so this says the demand D for a certain commodity. So demand D for a certain commodity is a function of the price. Okay, so this P value is the price. D is the demand. Okay. So when we are writing out what this means, we're going to say that the inverse represents the price, because remember, D inverse is the same as P. These are the same. Okay, so it's the price that is associated with the demand D. Okay, so when you do this, these are going to switch. So here it says the demand D is a function of the price. When you do the inverse, okay, the input and the output switch. Okay, so if you are having trouble with this, because this is something, again, that people get confused about, one thing I like to do to help me with that is if you have D of P, when you look at the original function, do you see that price is the input? And then your output is the demand. When you do the inverse, the input and the output switch. So now the input is the demand and the output is the price. Okay, so when you're explaining, you can use that to help you. Those are going to swap. Okay, and if you wanted to, you could also say the way this says it's a function of the price, you could say the price is a function of the demand. That would be fine as well. All right, now we have to find D inverse of 30. Okay, so D1 of 30 just means we are going to plug in 30 for D. Okay, so you're going to plug that into your inverse function. Okay, so when we do that, this would be a no calculator question if these were your numbers, just so you know. You'd have negative 10 plus 50, which would be 40. Okay, And then when you are writing what your answer represents, what I'm going to be looking for is that you are including something about the input and the output. All right, so keep in mind that what you are plugging in is the demand. So you can start by saying when the demand of a commodity is 30 units. Okay, so D represents the demand of a commodity, so we're including that. So when the demand of a commodity is 30 units, the price per unit is, and this would be $40. Okay, and that would be your explanation. Okay, so again, this is why writing this out is helpful, right? What you plugged in was the demand, what you got out was the price. All right, now we're going to consider a different narrative here. So with some of your problems, they're going to have the equation represent a value that's measured in a different quantity. So this is the demand D for a certain commodity where D is measured in hundreds, okay, is a function of the price. We have the same equation here because I just want to show you how this changes. And then explain what your answer in part B represents, okay? So we're just going to consider that D is measured in hundreds now. So for part B, okay, you have D of, oh, I didn't put my little -1 there. I have my inverse, okay, of 30 is equal to 40. In this case, if the input, D, is measured in hundreds, okay, then what we're going to have to do is we're going to have to do 30 times 100. Okay, if it's measured in hundreds, you're going to take that value, multiply it by 100. Okay, and then, so this would be 3 with 3 zeros. 1, 2, 3. Okay, so it's the same answer. You would still have this is equal to 40. Okay, you wouldn't plug anything different in. Okay, and we would just say when the demand of the commodity is 3,000 units, the price per unit is still $40. Okay, and I do just want you to know, like, the input does not change. Okay, you would plug 30 into the equation. You would not plug 3,000 into the equation, okay, because the equation is formed with this in mind. Okay, and the only thing that changes is your explanation. Okay, so now we're going to consider, it says the demand D is measured in hundreds while the price is measured in thousands. Okay, what would your answer in part B represent? So the demand is in hundreds. So we multiply by 100. If the price is in thousands, we take that value of 40 and we multiply it by 1,000. Okay, and then when we write our explanation, we include these in the explanation. All right, so why don't you guys give that a try just based on these two? We're going to start very similarly. Okay, so we can start with the same narrative. When the demand of the commodity is 3,000 units, the price per unit is $40,000. Okay, so I just did this with one example to make that a little easier on us. Okay, so and they didn't say what the commodity is. So in the last one, what type of commodity could they be referring to? What's something that would cost around $40,000? Yeah, a car. Okay, and then what about up here for $40? Oh yeah, I like that. How much are labubu's? Probably 40 bucks. Okay. All right, and then I just want to remind you, you do have to submit this into Google Classroom. Sorry, it's a lot of single problems. I handpick these.